mistakes here. All right. Great thing about this lesson is it is just combining the previous two lessons. So it's nothing really new. If we see a piece of a function that is decreasing concave up, I know the signs of the derivatives. I know f would be decreasing when its first derivative is negative. F would be concave up when its second derivative is positive. If something's increasing in concave up, its first derivative is positive, its second derivative is positive. So what we will be doing, and I'll continue to do the rest of them, is like, if I'm able to analyze the signs of a first derivative and a second derivative, I should be able to throw in a third line that will be the shape of f. And we're not going to be doing this often because it's pretty time consuming, but we'll do for a couple examples. But we'll see, like, we will be expected to be able to analyze both the first derivative and the second derivative at the same time. And then we will throw all of the very important numbers from both the first and the second derivative down. And we'll be able to, knowing signs, know the shape of f. If f prime is negative and f double prime is positive, well, if we are decreasing concave up, right there, f prime is negative, f double prime is positive. We know that until -2, my function has that shape. If between -2 and -1, I have the signs of f prime being positive and f double prime being positive. Well, f prime is positive, I'm going up. F double prime is positive, I'm concave up. I know the shape will look like this. Okay, so those first two pieces. And if you wanted to continue to put in, the behavior of f going down, then up, then down, then up, you can. F being concave up, concave down, concave up, you can. But not necessary if you just have done enough that you know. So let's go back here. Let's just make sure we understand the derivatives of the first and the second derivatives of a function that looks like this, like this, like this, like this, like this. Okay, go ahead and list off the derivatives for these two. If f is increasing and concave down, what's going on with the signs of its derivatives? Yep. F prime is positive, so we'll say f prime is greater than 0. F double prime is negative. F double prime is less than 0. If we are decreasing concave down, decreasing, its derivative is negative. Concave down, second derivative is negative. If we think about increasing no concavity, what would be the sign of the first and second derivative? Discuss with your neighbors. The first part should be easy. Something is increasing when, come on, discuss, wake up. It's after lunch, I know, but go ahead, let's wake up. Our first derivative is positive, our second derivative equals 0. No concavity, no acceleration. Decreasing, no concavity. Neither increasing nor decreasing without any concavity. Now, what is important is we need to be able to understand decreasing concave up, first and second derivative signs, but also different ways to say the same thing. I could say f prime is negative and increasing for this first box. And you will be asked questions like, hey, when is a function, when is f, or when is f prime negative and increasing? You need to be able to say, okay, f prime is negative, that's this. F prime is increasing, its derivative is positive, that's how I get that. So these are the same. We need to be comfortable with them being the same. Another way to say the same thing is f is decreasing at an increasing rate. This is actually the same as f prime being negative and increasing. It's the same as f prime being negative and f double prime being positive. F is decreasing. What is the rate at which it's decreasing? Well, decreasing is talking about the first derivative. The rate at which it's decreasing is talking about the second derivative. So if it's decreasing, the first derivative is positive. If it's decreasing at an increasing rate, that means the decreasing, the negative f primes need to be coming and be turning less negative, going to zero, going to positives. Very confusing. This is what's tricky about the tying all together, is the different ways of saying the same thing. F prime negative increasing, f decreasing at an increasing rate, f prime negative, f double prime positive. All the same. This guy, this guy, this guy, this guy. Okay, so we need to be comfortable with all three, all four, and you'll see questions in all four different ways. So let's go back to this. Understanding now those derivatives and the signs, we should be able to understand the shape of f. So next interval is from -1 to 0. F prime is positive, f double prime is negative, increasing concave down. Next interval. Between 0 and 1. F prime is negative, f double prime is negative, decreasing concave down. Last interval, or second to last interval. F prime is negative, f double prime is positive. We're back to being decreasing concave up. And then we finish off with increasing concave up. What I will be able to do, and we're not going to ask you to do it much. Instead, I will ask you more questions like, hey, when is f prime decreasing? Or when is f prime negative and decreasing? I'll ask you questions like that. But through this analysis, you would be able to sketch the shape of f, combining all these pieces. Until -2, I'm decreasing concave up, increasing concave up, point of inflection, increasing concave down, I'll have a max, decreasing concave down, I'll have a point of inflection at 1, decreasing concave up until 2, I have a min, and then up. Now, exactly where this is located, I don't know. You know, maybe all of these pieces are actually down here. Maybe we're actually going down more, coming up less. That stuff is not important. It's more of like an understanding of the shape. Okay? So, I'm only going to do this once, because then we'll just focus on just different questions that you'd see on quizzes and on tests. Here's the function. Accurately sketch this function. Let's first start by finding and understanding the shape of the function. But then we'll do one more thing to give us a better, accurate sketch of the function. All we will be doing is combining the last two lessons and combining the analysis of the first derivative, which we skipped last class, but we did the previous class, and when that changes sign, and the second derivative. What's going to be very important if you're doing this, I hope we're all doing it, and what helps me is to make sure I've listed off these possible sign change points, these zeros and these undefined values, with reference to the other ones. So if I have 0 and 2, and then I have 1 for my second derivative, make sure 1 is in between 0 and 2. We've done enough of these sign analyses that we should be getting quicker at like positives and negatives and positives and stuff like that. Please check your sign analysis with your neighbor. So for f prime, I plug in 3, positive times a positive. Plug in 1, positive times a negative. I plug in -1, negative times a negative. For f double prime, I didn't factor out the 6 because it's like not necessary to do so. Plug in 2, 12 minus 6. Plug in 0, 0 minus 6. Okay, fantastic. Now, if you'd like to, just to remember, the sign of a first derivative is telling me whether f is going up or down. The sign of the second derivative tells me if f is concave up or concave down. But don't forget, the sign of the second derivative is really also the way that f prime is changing. So if f double prime is negative, that means f prime is decreasing. We could throw in another layer if I wanted to. Maybe it'll help us with certain problems. Oh, f double prime is negative. That means f prime's prime is negative. That means f prime is going down. Maybe you include that for certain questions. Maybe it helps you. Maybe it doesn't. I don't know. But remember, the sign of a derivative tells us if something is going up or going down. Since f double prime is negative, f prime is decreasing. Not super important for this question because we just want the shape. If I know I'm increasing concave down, my shape is like that. Decreasing concave down, like that. Decreasing concave up, like this. Increasing concave up, like this. Now I can go ahead and throw that down on my xy axis, but I can do more because I am given the function. So not only can I just like throw down the relative shape of things, but I can find the exact locations, the correct locations of these maxes, mins, and points of inflection. I could plug in 0 into my function, and I get 3. So 0, 1, 2, 3, that's going to be the location of my relative max. If I plug in 1 I get 1 minus 3 plus 3, that's just 1. That is the location of my point of inflection. If I plug in 2, 8 minus 12, negative 4 plus 3 is negative 1. That is the location of my relative min. I got 3 points. It looks like they should be connected in a linear way, but we know that's not true. We know I'm going to be increasing concave down until 0. Then from 0 to 1, my shape is decreasing concave down. From 1 to 2, decreasing concave up. And then after 2, it's increasing concave up. We just did a phenomenal job sketching that function without the use of a calculator. And that's pretty much what this unit is all about. Understanding what a function looks like, its characteristics, its behaviors, by analyzing the signs of its derivatives. Hooray. Now, go 2 pages down. Cross off this guy, this minus 12x. This function is really very similar to the previous function. If I had the plus 3, the plus 3, the plus 3, but I don't. Okay? The next 3 questions I have on this page all refer to this x cubed minus 3x squared. But instead of asking you to accurately sketch, the questions become like, when is f prime positive and increasing? When is f prime decreasing? When is f increasing at a decreasing rate? So this all turns into, understanding of signs of the first and second derivative that you have to look at together, but more of like a, do you understand what you should look for when you're asked this question? Okay? Now we could go back and take our first derivative and second derivative sign analysis, because the derivative of x cubed minus 3x squared plus 3 gives us the same thing. So I'm going to go ahead and take this, and we're going to throw it over to those problems. So here we go. Edit, paste. Edit, paste. Because once you've done enough of these, it becomes very repetitive doing the sign analysis again and again and again. Okay? So we have the sign analysis already done. Our job is to find the correct intervals that we are asked to find. So coming to this one, we need to be able to take this question and go ahead and copy down the sign analysis. We need to take this question and make sure we know what we're looking for. And we're going to use this sign analysis for the next 3 problems. And I'll get rid of all this extra stuff because it might just get in our way. And I actually am going to get rid of, well, no, I won't get rid of the shape of f. Okay. Given f of x, whose derivatives we've already analyzed, tell me, when is f prime positive and increasing? please discuss with your neighbors first, like, what does it mean for f prime to be positive and increasing? Go. So there's multiple ways to think about this. I like how students typically think about shape. So if f prime is positive, I have positive tangent slopes. But if those positive tangent slopes are increasing in their values, they go straight here. And that's great. That's correct. When does that happen? X is bigger than 2. You could do that. I like to, because you will see with like the third example we'll do, sometimes it gets kind of confusing in my head. I like to just immediately switch this to signs. You know, f prime positive, okay, f prime positive, that's easy. F prime is increasing. That means the sign of its derivative is positive. F prime is positive, f double prime is positive. Okay? So I think that, and then I think, okay, I've done the positive negative sign analysis. When is f prime positive here? When is f double prime positive here? When are they positive and positive together here? So that would be my answer. X is bigger than 2, or from 2 to infinity, you need to be comfortable with both interval notations. Okay, please answer me. When is f prime negative and decreasing? Change it. Not just f prime decreasing, f prime negative and decreasing. Go ahead and discuss the answers with your neighbor. F prime negative, f prime decreasing, its derivative is negative. When is f prime and f double prime both negative? Right there between 0 and 1. If you understand that, then you're good. The third one, though. When is f increasing at a decreasing rate? Discuss this with your neighbors, and then I'll tell you how I think about it. Most of you are on top of this. It's increasing, but the rate at which it's increasing is decreasing. Or, if f is increasing, f prime is positive. The rate at which f prime is positive is decreasing. That means the second derivative is negative. It's increasing at a decreasing rate. That gives us this portion of the graph when x is less than 0. For some of us, it will take practice, and yeah, this is probably the more complicated one that students mess up on, is the whole f is decreasing at an increasing rate, f is increasing at a decreasing rate, okay? But if we're comfortable with that, then we're good. Let's go back, because we just already did that analysis, so we might as well just like, boom, go straight there, because it's the same function all 3 of the times. But let's look at this one. This is a different function. Please tell me, when is the function decreasing in concave up? You need to be comfortable with that question being the same question as f prime is negative and increasing. or f is decreasing at an increasing rate. Don't worry about the accurate sketch. Let's do the sign analysis to figure out when f is decreasing and concave up, which is the same as f prime being negative and increasing, which is the same as f decreasing at an increasing rate. We should get -4 and 0 and -3 and 0. Hopefully we got those values. I would recommend putting them down. -4 and 0, -3 and 0 in order. You could include the third line, but mostly the third line is to understand the shape, which is important. And if the shape helps you answer the question, great. But if you can translate f decreasing concave up or the other two statements into signs that you're looking for, you don't need the shape. We are looking for when f prime is negative and f double prime is positive. Be careful with the second derivative, because that x squared, the x cubed will change signs. The x squared will not. We will be able to see the shape of f increasing concave down, decreasing concave down, decreasing concave up, increasing concave up. But please answer the question. When is f decreasing concave up? When is f prime negative and increasing? When is f decreasing at an increasing rate? They're all the same. And the answer to every single one of these statements is from -3 to 0. Okay? That is when f prime is negative and f double prime is positive. That is when f prime is negative and increasing. That's when f is decreasing at an increasing rate. Okay? Let's go ahead and do this one. The next one is a little bit trickier, so I'll breeze through this one and then we'll slowly go through the next one. Same deal. When is f increasing concave down? You should be thinking about that saying when is f prime positive and decreasing. Or when is f increasing at a decreasing rate? Okay, I get x less than 1, or from negative infinity to 1. That is when f is increasing and concave down. That's when f prime is positive and decreasing. That is when f is increasing at a decreasing rate. All right, let's look at this x over x plus 4. This is a good one to make sure we're careful for maxes and mins and points of inflection. Got to use the quotient rule, first of all. A lot of us forget about it. Derivative of the top times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. In your homework, I gave you a chain rule problem, which is real fun. You'll even hear me be a little bit frustrated that I gave it to you. Now, that's x plus 4 minus x. So that's just going to be 4 over x plus 4 squared. This is not a great problem. Doing it anyways. Second derivative. Now, to find the second derivative easily, if you watch the rest of the last lesson of the second unit, I talked to you about how instead of using the quotient rule for something like this, it's best to rewrite it as 4 times x plus 4 to the negative second and use the chain rule, giving us negative 8 x plus 4 to the negative third times 1. Now, for both of the sign analyses of f prime and f double prime, we don't have zeros, but we do have situations where we have undefined at x equals negative 4. Remembering that when a derivative is, or signs could change at an undefined point, okay? Regardless of what you're looking at, when could sign change? When we are undefined. So don't forget about things being undefined. Don't forget about denominators being equal to 0. Whatever. All right. Now going back into my first derivative, I can see It's going to be positive. No matter what I do, I'm going to square the denominator. So even if it's -5, -5 plus 4 squared. The second derivative, we will have signs that change. If I plug in something like 0, it's -8 over a positive, so that's a negative. If I plug in -5, it's -8 over, -5 plus 4 is a negative cubed, will remain negative, so that becomes a positive. Now here's what we need to be careful with. Increasing concave up, sure. Increasing concave down, sure. A lot of us would like to connect these. Like that. But that would not be correct. Why? I know that if I plug in -4 into my original function, I'd get -4 over 0, which is undefined, which means I have a vertical asymptote at -4. I could go further. I don't know that I'm coming from -infinity and going up to positive infinity before this vertical asymptote. I could actually look at the limit as x approaches infinity of x over x plus 4, as well as -infinity, to see what's going on all the way over to the right, what's going on all the way over to the left. Remembering how we can just cross out the 4, it's going to be insignificant and just get 1, we can combine our knowledge from the previous units to say, I'm increasing concave up with a horizontal asymptote at 1. I'm increasing concave down with a horizontal asymptote at 1. And this would be the correct graph of x over x plus 4. The remaining problems we're about to do involve the graph of f prime, or the graph of f, and being able to translate what you're asked to do to get the answer. I will continue to do these examples. It'll take me about 10 minutes.
May I go to the library?
We need to be able to do a sign analysis of f prime and f double prime at the same time, given the graph of f prime. Remembering, if I'm given f prime, just look at the values of prime. They're positive until -1. They remain positive until what looks like 2. They are negative after 2. Meanwhile, f double prime would be the slopes of the tangents of f prime. Negative tangent slopes until this 0 at -1. Positive tangent slopes until the 0 at 1. Negative tangent slopes after 1. We can combine that to sketch f. -1, 1, and 2. We see we have a max at 2. We have a neither situation at -1, but we see that we do change concavity, increasing concave down to increasing concave up, increasing concave down, decreasing concave down. So something like that. If this is -1, this is 1, this is 2. Okay, but what you will mostly see is the graph of f prime, and you'll be asked questions like, when is f increasing at a decreasing rate? We need to be able to translate this. F is increasing when its derivative is positive. It is increasing at a decreasing rate with positive tangent slopes that are getting less and less positive. So the first derivative positive, second derivative negative. We need to be able to get that translation done and then do the sign analysis and find the interval in which f prime is positive and f double prime is negative. F prime is negative until negative 1, positive from 1 to 2, negative after 2. F double prime, slopes of the tangents of f prime are positive until a 0 here, and then negative after there. 0's at 1, negative after that. So when is f increasing at a decreasing rate, when is f prime positive and f double prime negative? That would be here between 1 and 2. I do want to sketch this. This is interesting. We are familiar with this function, the absolute value of x over x. It's either positive 1 or negative 1, depending on where you look at it. Well, f prime values are either negative until 0, where it's undefined, then positive. Well, f double prime values don't exist at 0, but they are 0 everywhere else. Decreasing, no concavity. Increasing, no concavity. And beyond that, you know, I don't have to say that it's negative. I can say it's legit negative 1, positive 1. This slope is negative 1, this slope is positive 1. We get our friend, the absolute value of x function. So really cool, really interesting, and we could have looked at it the other way. If I give you the absolute value function, what is its tangent slope generator? Well, it would end up being this. And we've seen this actually pop up on certain AP tests more recently. Well, look at this guy, this jump. What happens with this jump? I'm actually going to sketch this just because it's interesting to see and be comfortable with jumps or sharp points. Let's assume this is at negative 1. I have positive values until negative 1, negative values until 0. I have an undefined value at 0, positives after that. Meanwhile, f double prime, all of my tangent slopes are negative, undefined again, and then positive. Let's look at what the shape of f could look like. Increasing, concave down. Decreasing, concave down. Undefined, undefined. Increasing, concave up. We might end up with a situation where we have a vertical tangent, potentially, or we just have a very interesting sharp point. Increasing, concave down, decreasing, concave down. And then maybe we just decrease concave. Sorry, we're increasing concave up. I was wrong. This is wrong. Increasing concave up. Looks like this. So yes, this makes sense. If I go from decreasing concave down to increasing concave up, I have an undefined value for this derivative because it's a sharp point. We will find that we will have an undefined value for a second derivative if the first derivative is undefined, typically. So that would be the graph of f. So if I asked you when is f prime negative and decreasing, f prime is negative. Here it's decreasing there, so from negative 1 to 0. Remembering the questions I gave you with the second derivative when I gave you the graph of f, you will be asked to answer when f has certain characteristics, like f increasing at an increasing rate. You can either think about it as that, Or if I ask you when is f prime positive and f double prime positive, both of these you should be able to answer given f. Now, sometimes it's easier to see increasing, but the rate at which it's increasing is increasing. We can see like right there. Or you could think, when are we increasing and concave up? Here's where we concave up, concave down, increasing, concave up, -1, 2, 0. This is a similar one. Maybe let's just change it up. F prime negative and decreasing. No, that's a good one. When is f prime negative? When is f prime decreasing? F prime is decreasing when its derivative is negative. I can change this. I could get straight to my answer, but to make it easier on myself, I like to say, okay, f prime is negative when f is decreasing. F double prime is negative when f is concave down. When are we decreasing? Concave down. There. You'd also say f prime is negative and it's decreasing. It's getting more negative in its values. So from 0 to 2. As f prime positive and decreasing. F prime positive, f prime positive, positive and decreasing means that its derivative is negative. So it would be f is increasing and f is concave down. Increasing, concave down, increasing, concave down. You're told where you have points of inflection, so that helps you. I'd go from -infinity to -2 and from 1 to 2. Final question. This is the graph of f. F of 2, f prime, and f prime of 2, and f double prime of 2. Compare them. Well, f of 2, I can see is the point at 2. It's 0. F prime of 2 is the tangent slope to f at 2. I can see that's positive. F double prime of 2, I can think of as the concavity of f. You can see this function is, since the function is concave down, the concavity of f at 2 is negative. What you will be asked to do is list these in order, like on your homework quiz or test. So you'd say the second derivative of 2 is less than f of 2, which is 0, which is less than f prime of 2, which is positive. All right, that is it for Unit 3.